Hi guys, thank you for being here tonight. I hope you will enjoy this presentation. When we speak about exploiting during this presentation, I do not refer about putting some shellcode or doing some nasty technical stuff. But exploiting in this context means gaining some money from the internet banking applications. This is the agenda. A little bit about myself. I come from Romania. I work as a penetration tester at KPMG, Romania, and yeah, thanks. And I've been involved in quite a few web application penetration tests, including internet banking, mobile application penetration testing, network infrastructures, and so on. I also do some teaching at Bucharest universities. I teach penetration testing classes. And I'm a person who always likes to prove his point. Actually, when I do find some vulnerability, I like to prove that it's real, and I like to give arguments for this. Not only saying that it could be possible to be exploited like this, and someone could exploit it in the other way, but I actually do exploit it, and I do show how it can be exploited. And you will see this in the presentation. So let's talk about rounding. I'm sure that every one of us has seen prices like this: $1.99, $7.99, $9.95. Which one of you has ever paid $1.99 for anything that you ever bought? Did you actually pay the 99 cents or $9.95? Of course, everyone rounds it to 10, to 8, to 2, especially if there is a nice lady selling the product. What about if we buy two products and together they make 6.05? How much do you pay? Do you round it to 6 or you round it to 6.10? From my own experience, maybe you have other experience, but I usually round it in the favor of the seller. So in this case I pay 10, in this case I pay 8, in this case I pay 6.10. Please tell me if you have other experience. So if you're wondering, the seller, the one who sells you the product, how much does it win from this rounding stuff? It depends on the number of clients. If he has a lot of clients, the amount that can be won from rounding can be significant, in my opinion. So I say that we as persons are a bit vulnerable to this issue. If we make an experiment, not talking strictly about the persons in this room, but if you take a sample of, for instance, 2,000 people, and you show them two prices, the first price is $9.95 and the second price is $10, which one do you think they will choose? I bet that they will choose this one, because it looks smaller, but it isn't actually. You actually pay the same. So it's kind of a marketing trick. So I said that we as persons are vulnerable to this issue, but the thing that I'm saying today is that banks are also vulnerable to this rounding problem. This problem comes from several penetration tests that I did in multiple internet banking applications, and I found this problem in multiple times. Usually, an internet banking application specifies the amount that you have in your account with 2 decimals. You see here, in my in this test application, I had 2 accounts: one euro account and a RON account. RON is the Romanian currency, and the balance is shown with 2 decimals. Okay. So let's ask, what happens if we somehow manage to transfer this amount into one of my accounts? So 8.3436 into my euro account. The bank will have to round this vulnerability, this amount to 2 decimals because it has no other way to express it. So this will be rounded to 8.34 because the rounding is done to the closest value. Okay, so in this case, you put this amount in your account and you end up with less. You end up with 8.34. So in this case, the bank wins 0.0036 euros. Okay, but what happens if we try to transfer another amount, 8.3478. So I'm transferring this to my account, and I end up with more, with 8.35. So the internet banking application rounded this amount to the upper value. So in this case, the bank loses 0.0022 euros. Okay? So the rounding is done to the closest value, and the maximum amount that you can win or lose from such a transaction is 0.005 euro per transaction. If you say it's a very small amount, that is true, but think about if you're doing thousands and thousands of transactions, that can be rounded in your favor. I tell you that you can win a considerable amount. So how to always win? In these previous cases, so the answer is, let us make transactions that will always be rounded in our favor. So we are the client of the bank, we have an internet banking account, and if we do transactions, we can compute how much we will gain from a transaction. So we can make transactions that will always be rounded in our favor. How can we do this? The situation that I every time found to be vulnerable to this issue is in foreign exchange operations. If you transfer money between accounts with different currencies, of course you cannot do this attack with real money at the guichet, because nobody will transfer you 0.005 of a currency. So the actual result of this attack is that you can obtain a better exchange rate. This is an example from a real pen test that I did. So I had 2 accounts, a RON account and a euro account, and the official exchange rate was 4.4 RON per euro. So if you exchange 4.4, you receive 1 euro. It will be not rounded, it's 1 euro, and this is the official exchange rate. But what happens if we exchange lower amounts? So below 0.05, so above 0.05, it's not anything in our favor. But if we drop below 0.05, for instance 0.03, If we exchange this amount into euro, we receive this amount that will be rounded in our favor. So the actual exchange rate will be 3 in this case. The lowest amount that I could exchange was 0.023, which was rounded in the best way for me to gain the most from rounding. So 0.052 was rounded to 0.01, and this gave me the exchange rate of 2.3, given the fact that the original exchange rate was 4.4. So, if I do 100 of these transactions, micro-transactions I call them, you can actually gain from 2.3 RONs 1 euro. So you can imagine that you have to do really lots of transactions in order to exploit this vulnerability. This is a screenshot from the actual internet banking application. This is the transaction report. You can see this 003 exchanging to 001, and the best one 002. Exchanging 001. This is actually 0023 because the banking application did not show the third decimal. As you can see in the dates, this is 2012. This is more recent. This is actually this month. I did it in another application. This application fortunately had translation into French, so I took a screenshot to understand it better. So you can see that I could sell actually 0.025 RONs into 0.01 RON, giving the exchange rate of 4.46. Okay, so it says that the transaction has been introduced and has been signed and has been approved with success. There is a little trick here. I saw different internet banking applications. When you do foreign exchange, they allow you even to specify the destination amount, even to specify the source amount that you want to exchange. The best deal is if you can specify how much of the weaker currency you want to sell, because the stronger currency will be rounded. So you want to round the euros, not the weaker currency. So this is the situation when you can win the most. I have done a calculation here. So how is somebody able to win some money from this issue? Let's say you have an initial amount of the weaker currency, X RONs. You exchange this into Y RONs, doing microtransactions, doing lots and lots of microtransactions at the better exchange rate. And after you gained RONs, you exchange them back to the euros, you exchange them back to RONs at the official exchange rate. And you can win the difference. Because the official exchange rate will be much higher than the exchange rate with microtransactions. Okay, so here is an example. If you have an initial amount of 100 RONs, this is about 22 euros, something like this. You can gain in this step 190 RONs. No, the final amount is 190 RONs, and you can gain 20 euros from from doing lots of microtransactions and exploiting the rounding vulnerability. Now, if you ask how many transactions are required to win this amount, there are 4,347 transactions. Okay, we as hackers start to wonder, how can we automate this? How can we automate the internet banking application to do transactions automatically, and after we start the whole process, we just step aside and look at our program, how it's making money. The problem is easy in the situations when the internet banking does not require a second factor authentication for transaction signing. There are applications, I saw really few of them, but there are, which require you a second factor authentication just in the login step. And after you pass the login, you can do transactions without requiring a digipass or a token or anything else. So these applications are the perfect victim for this attack. After you log in, you start doing transactions automatically and watch the program making money. But there are also other types of more secure applications which requires you to have a physical device called digipass or security token that you must use in order to sign a transaction. We'll see how this can be automated also. How to fix? The banks should protect themselves by limiting the number of transactions that can be performed by a given person. For instance, in a day, a person should not be allowed to make, let's say, 1 million of transactions per day because it makes no sense. Companies maybe need to make them, but a regular person not. If they introduce a small fee for a currency exchange, for instance 0.01, this will eliminate the gain from the rounding. Or limit the minimum amount that can be transferred in an exchange operation. And more than that, the banks must monitor for suspicious transactions. From what I saw until now, the banks do monitor, but they monitor for transactions higher than a specific amount. They do not look at small amount transactions. But this is another type that should be also monitored. And it's really important to state in the contract that such transactions are illegal, because from what I spoke to some lawyers or guys in this legal field, they told me that the bank does not have a real basis for accusing you that you're exploiting this, because you're actually using the system of the bank. So you're not actually exploiting any vulnerability. You're just using the system as the bank gave it to you. Okay, right now let's go to the part of the exploitation. The general idea is to find a way to do lots of transactions in a relatively short time. Usually transactions are made in two steps. The first one is the initialization, when you specify the source and destination and the amount that you want to exchange. And the second step is the signing of the transaction, which requires you this digipass or token or SMS or something. The first technique that you can use is to initiate lots of transactions and sign just once. There are internet banking applications which allow you to do that. In order to initiate lots of transactions, I don't know if you can see, but this is a screenshot from Burp Suite in the intruder component. You can see here the amounts, the source and destination accounts, and just hit run, and it will run for 1,000, 2,000 times, whatever you want. And this is the result. This is a screenshot from the internet banking applications. You can see that all the transactions are the same. This is also performed this month. So 0.025 exchanging to 0.01, tens of transactions. And you have this button here, sign all selected orders. You see? So you initiate as much as you can and you sign all of them. This is a way to do lots of transactions in a short time. But this signing can be also automated. Stay tuned for the next chapter. The second technique is to use payment files. Most internet banking applications that I saw allow you to upload a payment file. They have a window like this, and the payment file is actually an Excel file with the details for the payments that you want to do. So you can put in this Excel file thousands of transactions, specify source amount, source account, destination, beneficiary, and the amounts that you want to exchange, and upload this file into the internet banking application, and then sign it just once. So this was the second technique. The third technique that you can do to sign lots of transactions automatically is a technique that I did not really put in practice, but I'm pretty confident that it works. You saw this type of digipasses, right? So when you sign a transaction, the bank will give you a challenge code, and will ask you to input this challenge code into the digipass, press enter, and the digipass will give you a response. The response you have to put back in the application, and the application verifies it in order to sign the transaction, right? Okay, but did you know that this digipass device generates every time the same response for the same input code? So we have this code 43015. If we input it now, we obtain an answer. If we input the same code after an hour, we obtain the same answer. If we input it tomorrow, we will obtain the same answer. So what stops us to create a rainbow table with digipass responses? I'm saying that this would be applicable for challenge codes for up to 5 digits. It will be a maximum of 5 nines possibilities. And this is possible because the response of the digipass is a function of the challenge that you input and some static data. This static data is synchronized with the server based on the client ID and the unique identifier of the device. And you do not have to compute all these responses manually, because I have this machine here. I will show it to you a little bit later, which can do this for us. And the fourth technique to exploit running vulnerabilities is to do transactions in real time. So in real time, have a piece of software that talks to the server and initiates the transaction automatically. You don't need to sign it. And after that, interact with such a device to ask him to type the challenge code, receive the response, and send it to the internet banking application. We will see that in more detail a little bit later on. So this fourth technique requires automation of the Digipass device. Okay, let's go to a little bit more technical part. Digipass automation. There are multiple types of Digipasses. This is with one button. How it works, you push the button, it generates your code. After about 30 seconds, the code expires, and you have to push the button again to generate another code. Some guy on the internet set up this website in which he presents his masterpiece of automating this type of Digipass devices. If you can see, this is a wooden box. The Digipass is here in this wall. This is the motor. This is a motor here, and it's the whole device is controlled by an Adrian microcontroller. And this is a web camera. Let's see how it works, because it also has a video.
Quand tu dans ta propre tête ça, si tu le dis vertement,
So, let's do it again. You can see it's dark, and a light appears, and then everything finishes. Okay, so what happens is when you press a button from your computer, the software will control this motor. The light appears in the box, and the motor rotates and pushes the button, and this web camera films and receives the code. This is one method of automation. This can be used. I think this can be better used in the first techniques that I presented before to automate. Okay. And this is my machine that you can see here. This is it. This is for a little bit more complex Digipass device. It's called Vasco 550. This device, in order to do something, it requires first a PIN code that you must enter. Press the equal sign, and then you have two options. You can identify yourself, or you can sign transactions. In order to sign transactions, you must input the challenge code and wait for the answer. This is exactly what this machine does. It actually simulates the human behavior when interacting with such a device. It actually pushes buttons. It is controlled by a laptop, and it pushes the buttons, and there is a web camera in the back, you will see it later, which gets the response and gets the code. I'm going to show a video of this machine. Okay, so this is how it works. This is the laptop that controls the machine. That is the Digipass down there, and you can see that is pushed several times. Here is what the web camera sees in real time. You can see that right now it inputs the PIN code because it is in the stars, and the response and the capturing. After this talk, I will be in that table in the left side, and I will put it at work. And if you are curious to see it, please come.
What?
Romanian style.
Okay. So the current performance of this machine is that it can do 10 transactions per minute. So a transaction is made in 6 seconds. A transaction meaning entering the PIN code, typing the challenge, reading the response, and doing authorization. OCR means optical character recognition. It's a process that allows me to obtain the digital code from an image that is taken by the web camera. So our previous example, you can actually gain 20 euros in about 7 hours. The maximum amount that you can multiply per day allows you to gain about 68 euros per day, which means about 2,000 euros per month. You decide if it's good or bad for you, depending on your salary. But if you do it in parallel on multiple bank accounts, you could say that it's a money-making machine. Regarding the technical implementation, these devices that are actually pushing are called solenoids, which are a special type of electromagnets. When they receive power by these two cables, they actually push the stick for a few millimeters, and after the power is released, they release the pushing device. I hope you like my visual drawing skills. If you're curious, I control this machine via a parallel cable, and these are the 4 pins that I need in order to control the 13 solenoids. So according to the code that comes here, for instance, if I receive 1001, this is a multiplexer which connects the input with one of the outputs depending on the selection of pins. So with using the 4 pins, I can select a maximum of 16 outputs, but I do not really need all of them. And these transistors act like relays. When the transistor receives current in the base, it actually makes a connection, and when the connection is made, the solenoid actually pushes the button. When it's released, the solenoid releases. This is the optical character recognition part. It was not so easy as I thought before when I started building this project, because it is highly dependent on the lighting conditions in the room. So here are the responses for regular lighting conditions. You can see that the OCR software recognizes the digits properly, but when the light is too strong, some digits cannot be recognized. Even more, if the light is too weak, also some digits cannot be recognized. But I can tell you for sure that I did it in optimal lighting conditions, and it works. It recognizes every time. Here are the development stages of this device. I have actually built it from scratch. Here are the components. I'm not an electronics expert, but I remember what I've learned in the faculty. it was not so hard to put in place this circuit. I had to do some mechanics stuff, and this is the end, the final version from the phone. Okay, so after, if you have some questions, I will be in that table and I will start this machinery and see how it works. Okay, this was my presentation. If you have any questions, please shoot. Thank you. You can find me around the room and buy me a beer and I'll answer all your questions.
I think we will have some questions, I suppose. Anyone has any question?
No questions?
Hello. I wondered which bank did you use to do that?
Okay. The light is very strong here. Please repeat the question.
Which bank did you use to do
Which
that?
bank did I use?
Yeah.
This is not relevant for the discussion. And even though, as a consultant never tells the names of the clients. Anyway, I have found this problem in multiple internet banking applications, in banks that are known in several countries, so it's not a local main bank or something like this. You can try a single transactions on your own banking account to see how it works. I don't think anybody will bother.
We have another question here.
Yes, in how many time you earn more money than you spend in building the machine and time you pass on building it? You understand? No?
Can you repeat?
Building the machine and time to build it, it costs money, and how many time did you repay you?
Well, I think the question is when do you have return on investment?
I actually did not use it to gain money. The time to build it was about 2 weeks. I did not stay full time on it because my wife was not very happy because I transformed the house into a shop. But the cost of this machine was below 200 euros. So I think the return of investment comes pretty quickly.
2,000 per month for 200 euros. I think it's
2,000 per month.
self-explaining.
Okay, other question?
Yeah, you said that you use the mechanism system for typing in the buttons, but why not use, for example, electronic device, for example, CMOS, to put, not to put, but to make an encryption and...
I understand. So when I started building this machine, I had two options. This is called instrumentation. So I could do it via electronic means. This meaning I actually disassembled such a device, and I could see the contacts and the pins and everything. In order to push a device, you actually had to make a contact between between us to make a contact. Yeah, and this was not very difficult to do. But in order to read the response, there is this LCD. So this LCD that you see here, on the inside has more than 60 pins. I did not find the producer, and I thought it was pretty difficult to try to get the code only from electronic impulses and something like this. And another reason is that this type of instrumentation, this is external instrumentation, can be applied to any device, to any type of device. Just modify the structure of the solenoids and the position, and can be applied to any device. And even more, when I was at the bank and I told them that I was going to build this device, of course they did not believe me. They told me you cannot disassemble the device because it will deactivate. But it actually didn't. So I could disassemble it and it continued to work. The only condition was to keep the power on. If you take out the battery, it really disconnects. But think about it, the banks will buy the cheapest of these devices. They will not buy the most expensive devices which have protection measures and something like this. Okay.
Okay, I have a question for you, Adrian. Are you mostly into electronics or into software development?
No, I'm mostly into software development, but I did like electronics since I was a little kid. And during the faculty, I did not have the time to make an interesting project. And right now, I found the right motivation for that. And it really was not very difficult. If you know, if you know pretty well the concepts, you can adapt them easily.
Okay, thank you. Thank you, Adrian. Thank you very much.
Thank you.